Okay, this is justify number 4 for compacted IM3. From n piles of 12 coconuts each, I'm able to make blank piles of 3 coconuts each. So let's just take a look for a little bit about, before we take a look at student responses. If there are n piles and there are 12 coconuts each, then if you multiply that, that will equal the total amount of coconuts. If we reduce the amount of coconuts in each pile, right, maintaining the total amount of coconuts, then is there more piles now or less piles? Well, if the coconuts are the same amount total and we reduce the amount of coconuts in each pile, then we must have more piles. Okay, so definitely the amount of piles needs to be more than n, and all of these are all options. Okay, let's take a look at some student responses. This one earned a check plus plus. From n piles of coconuts each, I'm able to make 4 n piles of 3 coconuts each. So there's the claim. They're telling us that 4n is the answer. If any number was entered in as n, and that substitute of n was multiplied by 4 on the blank space in the question, then it would make the equation true. So there's no equation given, so what is the equation? For example, if 2, if n was 2 and there was 12 coconuts in each of those 2 piles, then 12 times 2 is 24. So 24 would be the total amount of coconuts. If 2 is n, then 4 times 2 is 8, which means there would be 8 piles of 3 coconuts each. Then it would make this equation true, because 2 piles of 12 coconuts is 24, and 8 piles of 3 coconuts is also equal to 24. So they keep referring to an equation, which gets confusing because there's no equation given, but this is the equation they're referring to, right? That same equation that I had up there, where the total amount is always the same, but the number of coconuts is reduced in each pile, which would increase the amount of piles. Okay, so there's their substitution, and then they get 24. So any of the addition answers could not be the answer because nothing in this equation is being added. It's multiple groups of coconuts, which would be multiplication. So they got a check for the elimination of the adding, and then a plus for pretty good explanation of why the answer is 4n, but they kept referring to this equation, so they didn't get 3, they just got 1 additional. So they still got 1 additional extra. Here's one that reads, n plus 3 cannot be the answer because if we were to substitute the n for 2, then the equation would be 2 plus 3 is equal to 5, and we would have 2 piles of 12 coconuts and 5 piles of 3, which does not add up because 2 piles of 12 coconuts is 24 and 5 piles of 3 coconuts is 15. So you can see how they're not equal. Okay, so that's a good elimination. If we continue to substitute for n for 2, then 4 times 2 is equal to 8, which means 2 piles of 12 coconuts and 8 piles of 3 coconuts, which does equal the same amount because 2 piles of 12 coconuts is 24 and 8 piles of 3 coconuts also equals 24. So this was chosen. There's that 4n. Okay, they might have benefited from just reiterating that 4n was the answer because they just showed the multiplication, but that's sufficient. They eliminated one solution and then checked the other one, which was the 4n. Here's a pretty short one and still received full credit, more than full credit, 2 extra points, check plus plus. if n is 5, there would be 60 coconuts. 5 times 3 would be 15. 15 piles of 3 would be 45, so it can't be 3n. Okay, so they eliminated 3n. To eliminate an answer, all you have to check is one substitution that isn't correct, so that automatically eliminates that. 5 times 4 would be 20, and 20 piles of 3 coconuts each would be 60 coconuts, so it's 4n. Okay, so then they checked that one, and that did work. And that is really only one substitution that verifies this. So I mean, they could have checked the other ones as well to eliminate those, but I did give that a check plus because it was pretty straightforward. Eliminating adding. Okay, so these two eliminate adding as well. And this one got a check because there's not a lot of reference to the units in these numbers, and that's really important when you're looking at context. This one here does talk about the word of, and so that automatically translates to that multiplication, and they elaborate pretty good on that. Okay, this one here attempts to generalize the computation, so they use the variables, which is great. Just make sure that the units are also in addition included in your explanation. So there's that 12n, that's the total amount of coconuts when you have 12 coconuts in each. Here is the total again with 3 coconuts each. But then if you have that x, and this is the number of piles, xn. And when they solve for 4, they're solving for x. And here it's let piles be xn, not just x, because xn is the number of piles. Okay, but that was a good attempt at showing that work. Okay, so there was some credit, but not complete. At least an elimination point for this part right here. Let's see, generalization here. 12n divided by 3 is equal to n. So n can't be two meanings. It says let n be equal to 4. And so if we put 12 times 4, then divide that by 3, that's going to not equal that same n. So this part could be eliminated. This part right here, though, is useful. It's really all you need as long as you explain what this means. The total amount of coconuts, which is 12n, divided by 3, right? Because now you're dividing the total amount by 3 because there's 3 coconuts in each pile. That will help you find the amount of piles. So you can take 12n, divide that by 3, and then you get 4n is the amount of piles when you have 3 coconuts each. And here's a really good one that really uses the context of the problem. 4n works because if you divide 12, the number of coconuts originally in a pile, by 3, then you would get 4, meaning that for every pile of 12, you can make 4 piles of 3. Okay, this one is this sentence right here is really useful in understanding what that 4n represents. And then they do their elimination, but I wanted to point that out. So that's it.